Alright, welcome back. This is 6.1, problem number 8, and it's about finding the volume of a wok. And so it's like a little frying pan, right? And it gives us this diagram, and then it asks us to calculate the volume of the wok in centimeters cubed. So it gives us this diagram where the y-axis is straight up, the x-axis is to the right, and then it tells us what equation governs the shape of the bowl in all dimensions. So that shape is drawn here with dashed lines in black, and the formula is x squared plus y squared equals 15 squared, which means we're looking at a circle with a radius 15. Also, x squared plus y squared equals 225. So my first step in using revolutions of solid is always, especially if they give a three-dimensional drawing, is to always draw it in 2 dimensions. Because our strength here is that there's an axis of symmetry here where we can sweep out the same graph in this direction and get the volume of the bowl. So let's draw it from the side. So now I've got my y-axis up, and I got my x-axis out. And you'll notice here, it told us that the brim of the bowl is 5 centimeters down from the origin. So if we're looking at the brim of the bowl, it starts 5 centimeters down from the origin, and that would be the ordered pair 0, minus 5, right? Because we're 0 on the x, and we're minus 5 on the y. And then we've got, of course, here's kind of the general bowl shape for this 1/2 of the bowl, anyhow. Alright, so there's our general bowl shape, and we're only going to kind of just worry about half of it, because we can revolve this half 360 degrees using the revolutions of solids to find the total volume. So the next step is going to be to draw our small chunk of volume, but first we need to pick a direction of integration. So you'll notice that from the brim to the base is 10 centimeters in the y direction, which means that our ordered pair down here is 0 minus 15. Now we seem to have some pretty forward boundaries for integration if we go in the y direction. The boundaries would be, we would be starting at, let me write this out. So we would be starting at negative 15, and we would go to negative 5. So b would be when y equals minus 5, and a would be when y equals minus 15. So that points us towards picking our infinitesimal width here. Let's pick something like this. So here's our small chunk of width. It's our infinitesimal width, and you'll notice it's in the y direction. So that means that this length right here, we're going to call that dy, because it's an infinitesimal in the y direction. Now with revolutions of solids, we're going to be revolving this out into disks, and then we're going to sum up all of those disks to find the volume using integration. So let's go ahead and draw a picture of revolving this out into 3 space. So into 3 space, you'll notice that this disk is perfectly circular and also has a width of dy. So this is our infinitesimal width, and then we're also going to have a radius. I'm going to call it big R. So what is big R in terms of this entire, because the thing about calculus is that we're zooming in on a small infinitesimal slice of something, but the rules we will lay down for integration has to work for if you pick this slice here, or here, or here, or here, or here. So it needs to work for every possible slice over the whole interval. Well, it seems to me like the length of this